Friends, today we are going to discuss the topic known as LVDT. The full form of LVDT is Linear Variable Differential Transformer. Today we are going to discuss about the construction, principle and working of LVDT. Okay, let's start. Why we need LVDT? LVDT is used for translating linear motion into electrical signal. Okay, now we can see the construction of LVDT. See, in LVDT we have one primary winding and two secondary winding which is wound on a cylindrical halo. Okay, this primary winding is connected to an alternating current input, and the secondary windings, two secondary windings S1 and S2 have equal number of turns. Let me see here, let me show here. See, there are how many number of turns? There are six number of turns: 1 2 3 4 5 6, and here also they have 1 2 3 4 5 6. Therefore the two secondary windings have equal number of turns. Okay, the winding of first secondary winding is known as S1 and the second secondary winding is known as S2. Okay, now this, and there is a movable magnet core or soft iron core which has a arm through which we will displace the core and we will place in certain positions. Those positions may be of null position. Those positions may be of the null position, or left to the null position, or right to the null position. Okay, let us see the working of this. We can know the working of the linear variable differential transformer. Okay, here first, when the core is placed in its null position, equal voltages are induced in the two secondary windings. Okay, when the core is placed in its null position, equal voltages are induced in the two secondary windings. The frequency of the alternating current applied to the primary winding ranges from 50 hertz to 20 kilohertz. Okay, the frequency ranges from 50 hertz to 20 kilohertz. Okay, the output voltage of S1 is known as ES1 and the output voltage of S2 is known as ES2. Okay, here the output voltage of S1 is known as ES1 and the output voltage of S2 is known as ES2, and these S1 and S2, okay, these S1 and S2 are connected in series opposition. Okay, these are connected in series opposition. Okay, these are connected in series opposition as shown in the figure. Now, hence the output voltage of the transducer is difference of two voltage. The output voltage is obtained by the formula ES1 minus ES2. Okay, here the output voltage of the LVDT is obtained by the formula ES1 minus ES2. Okay, now we can see the how we will get the various. Now we can see how the LVDT works when the movable magnetic core is placed in various positions. Okay, see this position of when the core is placed at the center of the cylindrical halo. See, this position is known as null position. When the core is placed in the null position, both S1 and S2 have the flux linking same. Okay, when the core is at its normal position, the flux linking with the both S1 and S2 is equal, and hence electromotive force induced is equal. Okay, therefore hence as we know that when both the secondary output of the secondary voltages are secondary windings are equal, then it is given by the formula ES1 is equal to ES2. Therefore the output voltage obtained is 0 when the core is placed in its null position. See, when the core is placed to the left of its null position, when the core is placed at its left of its null position, more flux links with S1. See, when the core is placed to the left of its null position, more flux is linked with the S1. and less with S2. Okay, as this core moves to the left side, therefore the more flux links with S1 and lesser flux links with the S2. Therefore the hence ES1 is greater than ES2. Okay, hence ES1 is greater than ES2. Thus the magnitude of the output voltage is ES1 minus ES2. Therefore the magnitude of this is nothing but ES1 minus ES2, and is here the ES1 is in phase. Okay, similarly if the core is moved to the right side of the null position, the flux linked with the flux, see, if the core is moved to the right side of the null position, the flux is more linked with the S2 than the S1. Therefore S1 links with the less number of flux when the core is moved to the right side of the null position. Okay, and thus the ES2 is in phase with ES2 is in phase. Okay, in this condition when the core is placed to the right side of the null position. Okay, and therefore the output obtained here, the output obtained is ES2 is greater than ES1. Okay, therefore the output formula is given by, that is nothing but E0 is equal to ES2 minus ES1, and then the amount of voltage change in either secondary winding is proportional to the movement of the core. See, as the movement of the core changes, the EMF induced in the primary and the secondary winding also changes. Therefore, the output voltage is directly proportional to the movement of the core. See, as soon as the current flows in the primary winding, it produces a magnetic flux around it, and the operation starts when the core moves in various positions, as I have explained earlier. And this is all about LVDT, and here we can see these are all the various positions of LVDT in which it works. I have already explained this. Graph are written in the, okay, this graph shows the variation, variation of output voltage versus displacement. See here, the various parameters are given and how does it works, and these graphs are very helpful in exam point of view also. And thank you, my dear friends. If you understood, you can please comment below and express your opinion. Thank you.